okie dokie. Changing bases. Your base, every time you have an exponent, we talked about y equals a times b to the x. Bless you. Your base is b. Your base is always the big number under the exponent, okay? So every time I say base, it's always the big number under the exponent. You can change bases by pulling out, so you change base, so 2 to the x equals 16. You can rewrite 16 with a base of 2. So 2 times itself so many times will be 16. The questions I ask you to change your bases, it will work. Okay, so you can't say it won't work here. The questions I ask you will work. That doesn't make sense right now. You'll see in a second as we start getting into it. So we're going to write 9 to the 2x as a base 3. Okay, so I can rewrite 9 as a base 3 because what is my exponent here? I know that 9 equals 3 squared, right? So I can rewrite 9 as 3 squared, and I still have this 2x out here. Okay, so leave 9, put that in brackets, and then put the 2x out there. So we want this right now, because 3 squared equals 9, and I still have my 2x as an exponent. Okay, if I have a power of a power, what should I do to those exponents? Multiply. I think you guys have these exponent laws. I think we went through them last unit. Okay, let me put it down the page number. Holy smokes, that was a long unit. 191. Page 191, exponent laws. So power of a power, you multiply. So what is 2 times 2x?
4.
Yep. So when I'm rewriting 9 to the 2x with base 3, I have a base 3, and I just combine my exponents. Okay, does everyone kind of see where we're going with this? Okay. You might ask, why the heck are we doing this? The reason why we're doing this, and before we're solving equations, is that if I have the same base, so if I have 3 to the 4x equals 3 to the 16, if I have these, I can solve for x. If I have the same base, and then I have a variable in my exponent, I can go 4x equals 16, x equals 4. I can solve like that, okay? Because if I have the same base, I can set my exponents equal to each other and solve for my variable. This is where we're getting with this, okay? Okay, 125 to the 2 minus x, and I want to write it as base 5. So sometimes you're going to use a little bit of guess and test. So you have your calculators. Oh yeah, you already know, cube it. So I know that 5 cubed equals 125. So I go 5 cubed, put it in my brackets, and then I have 2 minus x out here. Okay. So I have 5 cubed, all to the 2 minus x. I'm going to try to call Dewberry one more time. They should be here today. Nope. Oh, maybe. Oh, well, we got them on video at least. I don't know if they're here or not. Anyways, okay, so if I have 3 times 2 minus x, the big thing here is you have 2 different terms, okay? So 3 is being multiplied to 2 and the x. So if 3 times 2 minus x, this is your distribution loss, okay? So 3 times 2 is 6. 3 times negative x minus 3x, okay? So it'll be 5 to the 6 minus 3x. Okay, so be careful there. It's not just 6 minus x. It's 6 minus 3x. sometimes you have two different numbers. If I say 8 times 16 to the x to base 2, I can write 8 base 2. I can write 16 base 2. So 2 to the exponent, what is 8? Yep. Times 2 to the exponent, what is 16?
4.
It is 4. Okay, now that I have the same base, I can put both or everything here together. So first off, let's work with our the one on the right. So I have 2 to the exponent 3 times, what's 4 times x? Does anyone remember our power law? When I'm multiplying two powers, what do I do to exponents? You add the exponents when you're multiplying two powers. So if I have two powers with the same base, which I do, I add the exponents. So this is just 2 to the 3 plus 4x. Okay? Yep, that's as far as you go. So this right here is your answer. Any questions so far, guys? Okay, so I want this to base 2. So you are going to have to know this rule. If I have a to the negative x, this will be 1 over a to the positive x. Okay, so this is a rule you're going to have to know. And if I have 1 over a to the negative x, this is the same as a to the positive x. So if you ever have a negative exponent, it doesn't say your answer is going to be negative. It's saying that you're just putting it either on the denominator or the numerator. You're just putting it opposite of what it is. And then writing it with a positive exponent. So that is one of your exponent laws. Okay? So knowing that, can I write 1 over 512 with a base of positive, or with a base of 2? So I don't want 2 on the denominator. I want a base of 2. 2 to the exponent, what is 512? It's not half. Yeah.
Okay, wait.
So this is where the guess and test comes from.
2 to the base. Yes.
Well, it's like educated guessing. So you just throw a couple numbers and then you're like, oh, I need to be higher. So
9.
2 to the exponent 9. So 2 to the exponent 9, don't write this down. Sorry, don't write this down. I'm just going to talk. So 2 to the exponent 9 equals 512. Okay? How do I write 1 over 512 with a base of positive 2? Looking at these rules, yes. Okay? So I'm going to erase all of this. I told you not to write it down. So 1 over 512 is the same as 2 to the negative 9. And then I still have my 3 to the x. I think I maybe missed a step here. Nope, we're good. And then I still have the 3x there. Okay, so I power, what do I do to my exponents?
Times,
Multiply. Yeah, so 2 to the, what's negative 9 times 3x?
negative 27 x. Said x.
Good.
I did not say. Triple x? I did not say triple x.
Okay, now I want a base of 2/3, okay? So I can write 16 with a base of 2 and 81 as a base of 3. So, we've already done, guys, pay attention please. We've already done 16 as a base of 2. What was that? Haven't we? Yeah, right here. 2 to the exponent of 4. And then 3 to the exponent of what equals 81? And then I still have x plus 5 on the outside. Since you have the same exponent here, I can rewrite, okay, I'm just going to side note this. You don't have to write this down. 2 over 3, it's easier to do this with video. I can rewrite this as 2 over 3 all to the exponent 4. Because if you put it on the outside, it still goes to the inside, right? Because it goes to everything on the inside, so those two are equal. Okay, so knowing that, we can get rid of the 3 in the denominator and the numerator. So I can write this as 2 over 3 to exponent 4 to the x plus 5. Okay.
I said shot.
Yeah, now I have to put it all together. How do I put it all together?
So it's 4x plus 20.
Perfect. Don't forget to distribute the 4 throughout. X plus 20. Okay, grade 12s, are there any questions with how to do this? Just changing your bases and exponent laws. Are we okay so far? Okay. Okay, how do you get to 20? Because it's 4 times x plus 5. You have to multiply the 4 to both. So 4 times x, that's where that 4x came from. And then 4 times 5 is where that 20 came from. Okay, so like I said, put your phone away. Like I said before, exponential equation, put your phone away.
No, he was just trying to video.
Put your phone away, guys. Exponential equation with the variable is exponent, and then your base is what's under that variable, okay? So you're going to, guys, use this procedure to solve an equation where the variable is the exponent. So you write each side with the same base, like I told you why we're doing this. So we're going to put each side the same base. Going to use exponent laws to help us out there. And then once you have that same base, you can set your exponents equal to each other and solve the equation, okay? So this is basically what that's telling us. So solve this. I have same bases here. So once I have that same base, I can just go 2x plus 3 equals 7. Yep. So now we are solving for x. So to solve for x, you do your addition and subtraction operations first. So get rid of the 3.
9 minus 7,
2x equals 4. And divide by 2. Always do the opposite operation. So x equals 2.
Thanks, Allie.
Okay. 7 to the x minus 2 equals 343. I have different bases here. Can I change bases?
Yeah. If it's equal to.
It will be. These ones are. Okay. So
Everyone just knows this.
if I ever, like I said before, if I ever ask you a question like this, you will be able to write this with a base of 7.
Okay. 7 to the 2.
No, 7 squared is only 49.
So it's 3.
7 cubed?
Okay, sorry, I did it wrong. Okay. Yeah.
Is it 7 cubes?
Yeah. Yes.
Okay. So I have 7 to the x
You're so smart.
minus 2 equals 7 cubed. Is everyone okay with that? Is everyone okay with this step? I'm going to...
What, Dylan?
Oh, but now it's free.
Do you see it? Okay. So now that I have the same base, what do I do?
Then you just get rid of the 7, so then you make the exponents equal to.
Set your exponents equal to each other. X plus 2 equals 3. How do I solve for x? Add 2. X equals 5. Try to do this next one on your own. I'll give you about 2 minutes. So you have different bases. So first off, you're going to have to write 81 with a base of 3. Yeah, so now you're going to have to put it in brackets like we did on that first or that last page.
This is making me anxious. I don't want to do this.
It is 3 exponent 4. 3 times 3 is 9. Times 3 is 27. Times 3 is 81. 4.
So then I go 3 times 3 to the 4.
Yeah, 3 to the 4. 3 to the 4, and then outside those brackets is 3x.
Okay.
I'll write down that separate.
So then you multiply the 4, and then it would just be 3. That one. So then you would multiply those two terms into the little spaces.
Yeah.
What? Oh.
Is everyone okay with this step so far? You guys got that? Yeah. You remember how to isolate x when it's on both sides of the equation? You can add or subtract one to get to the other side.
Yeah. When you just, yeah.
Add x to one side.
Yeah. Are you guys stuck here?
Yeah. Is that right? You just subtract 5x and then it would be
Yes.
7x.
Yes.
Yeah.
Okay, those of you who are stuck, if I have 5x minus 1 equals 12x, I have x's on both sides. Okay, so I want to get all my x's to the one side, my numbers to the other side. Every time I solve an equation, that's what I want to do. I want to get my variables to one side and just the numbers on the other. So I have 5x minus 1 equals 12x. You can just subtract 5x from both sides. The reason why I'm subtracting 5x here and not the 12x is because I still have this 1 on this one side, and I don't have any numbers on the other side. So I may as well get rid of the x and put it on the other side. So this will say negative 1 equals 7x.
Yeah.
Okay? I'm just subtracting. Now to isolate x, you would just divide by 7.
Okay, so I have a question.
Okay?
Does when, like, you know how the bases are 3 or whatever, how come it just disappears? Just because they're equal to each other?
The bases are 3.
Yeah, like,
The base doesn't just, okay, this is still your equation, but now you will know what x is, okay? That's all we're doing. All we're doing is solving for x.
so the
Okay.
3's are still there.
Yeah, so the 3's are still there, but we just want to know what x is. Make sense? So what did you get for x? X equals? Negative 1 over 7.
Oh, shit. Okay.
Yeah, you still have to isolate x. Get it back. No, we'll do d together. Why is Every time I say something like that, I'm like,
I didn't laugh first.
Steve said.
Stop talking about the D, baby.
Brandon and Allie both look.
I knew you were laughing.
Okay, let's get our heads out of the gutters.
Can you just,
No.
hold on?
Okay, guys, focus. 3 to the x. That looks good, so we'll just leave it as 3 to the x. Equals. Can we write 27 with a base of 3?
Yeah. 3 to the
3
3.
cubed, yeah. And then I have the square root of 3. Do you remember how to write a square root of 3 with an exponent? I had it written down over here.
I don't know. X to the, oh, shit. Why doesn't it work?
Make a fraction. This isn't your exponent law, so you might have to actually know this. I think you might. So, if it's a square, okay, the square root of x is equal to x to the 1/2. Okay?
Can you just put it over 1? Does that work?
Put what over 1?
If we have a 3 though, it's just 1 over 3.
No, never mind. Never mind. It wouldn't work. Never mind.
Yeah. No. 3 to the 1 over 2. Because the square, okay, every time you have a square root, your index is 1/2. If you have the cubed root of x, it'd be x to the 1/3. Do you see where we're going with this?
Yes.
The fourth root of x would be x to the 1/4. Okay?
Oh, so it's 3 to the 1 over 2, isn't it?
Yes.
I'm sure it was.
So this is times 3 to the 1/2. Okay? It's a tricky law, but it's something you have to know. Okay, so now I have 3 to the x. I can just leave it as 3 to the x equals 3 cubed times 3 to the 1/2. If I have a power times a power, what do I do to the exponents?
They're the same, aren't they? So
You add. You ever have something like this? You add the exponents.
Oh, right, yeah. Okay, so 3.
3 plus 1/2.
1 over 3 is 1 over 3, isn't it? Oh, crap. Isn't it 1 over 3? I swear to God, it's 1 over
7 halves.
2.
7 halves.
I don't know where I was getting with an improper fraction. That's the word. The word is the word. The word is the word.
Oh my god. Okay. This is a big step. Is everyone all right with it?
Yeah.
Okay. Yep. 3 plus 1/2. Because if I'm ever multiplying 2 powers, I add the exponents. Are you okay with that so far? Yeah. So when I'm adding fractions, I need common denominators. So my common denominator is going to be 2. So this will be the same as 6 over 2 plus 1 over 2. So 6 plus 1, 7 halves. You're welcome. Again, if you want to put this in your calculator, I can't tell you not to on a diploma, okay? So just go 3 plus bracket 1 divided by 2, bracket, enter, and then put into a fraction. It'll say 7 halves. Okay? Okay, so what does x equal to then? Yep. X is just equal to 7 halves here.
That was a C, but it was like
Really?
it hurt.
Okay, we're going to stop there. We'll do 4 and 5 on Monday. Okay, so we're going to do 4 and 5 on Monday. I'm going to go over the exam. If you are fine with the exam,